Hello all. Now in this module, you will learn how to install, set up and configure Git on different operating system. You will also see the different configurations possible. You will be creating an account on GitHub and will see different options available on it. So let's start with installing the Git. Now Git can be installed by downloading the particular installer for belonging to that operating system. For example, for Windows, you can go to this particular link which will download a .exe file. Once the exe is downloaded, you can double click on it to execute it and then follow the instructions. Same is the case with the Mac operating system, wherein there are two options available to you. Either you can use the brew package manager and use this command brew install git, or you can download the package, which I am assuming will be .dmg, and then install it. Same is for Linux. For example, on Debian or on Red Hat, you can use the apt get install git and then it will be installed accordingly. Once the git is installed, you can verify the installation by checking the version. So to check the version, I have to execute this command. And for example, right now I'm using 2.19 version of Git, which can be a little bit old since this is I have already installed it on my system. Let's look at understand how the Git configuration works. So Git operates in a more customized fashion by introducing several important configuration settings and the hook system. Through these configuration, there are many ways in which we can configure how the Git will operate. So generally or in all, there are three ways to manage the configuration, which are arranged in the order of preference. The first one is command line options, second is environment variable, and the third one is configuration files. Now these are the three ways to manage the Git configuration. We will look at all of them in more detail. So through command line options, you can change various settings in Git. Now these settings can be executed in the hierarchical manner. That is, they change the behavior in a hierarchical manner. This is done by giving priority to the most specific one and so on. The second option we have is the environmental variables. So Git will always run inside the bash shell and uses a number of shell environment variables to determine how it behaves. Occasionally, it comes in handy to know what these are and how they can be used to make Git behave the way you want it to. Export statement, for example, is used to broadcast the environmental variables to subprocess. Now, these export statements are not the general Linux export statement, but these are more sort of the Git configuration commands. For example, some variables can be used with all core Git commands, while some are specific to given commands. These all are specific to the current shell. Third one is the Git configuration file. So Git configuration file contains a number of variables that affect the Git commands behavior. Settings for all users on the system and all their repositories can be configured this way. This is we're talking about the system-wide configuration file. And for reading and writing from a specific file, we need to pass this dash dash system option to git config command. We will look at the git config command in more detail. Generally, the file for system level configuration resides in these directories. For example, for Linux, it is in etc-gitcon, while for Mac, it is in $home.gitconfig. By $home, we mean the user's home directory. For example, if I go to this and I have this file which was created on November or edited on November 30th. The next place after the system level configuration is root.config/git/config, which is specific to each user and affect all the users repositories. This is generally called as the global level configuration, and it belongs to a particular user and will affect all the users repositories. Again, this path may or may not exist. This is not mandatory, but if it exists, then the configurations will be applicable in the hierarchy, which I'll explain in the coming slides. For example, does not exist on my system. Again, to read and write from this file specifically, we have to specify the dash dash global option. In the last, the Git will look for project specific file in the project directory. That is the directory wherein our repository exists, or you can think of project directory as the general your project's home directory. So these files will be in your project.get/config. For example, if I have a dummy project created, and if I look at all the files, then I have .get, and if I look into .get, then I have this directory structure wherein I also have the config file. So let's understand the git configuration commands. So git config is a command to set and configure variables which can be used to control the Git's look and different operations. The variables are stored at three different levels, which are system, global, and local level. And the order for priority for configuration level is local, then global, and then system, which means when looking for a configuration file, Git will start at local level and bubble up to the system level. From green to, this is like, for example, the first, then it will look at global, and then it will look at system. And each level values override values in the previous level. For example, local will override global, global will override the system, which is also mentioned here. etc config, if you remember, is the system level file, and .get config is my local level, which is residing in my project directory here. Let's look at more deeply onto the system level configuration. So system level configuration is applied across an entire machine. This covers all users on an operating system and all their repositories. According to system configuration, the administrative or super privileges may be required to change this file, since we're talking about system level configuration. Now the command for this is git config -- system, and then we can specify the user.name. So let's try this command. So what I'll do is, I'll now git config is my main command, and then I will have to specify the system and then the variable I want to, or the configuration parameter I want to set. So let's set it Edureka. And if I list it, let's see if it works. So if you see now, I have the Edureka username created. I can also modify it. Let's call it Edureka new, and then if I list it, then I have Edureka new, or I'll either create an Edureka system, so that when we'll install the parameters in the coming slides, then we can identify it very clearly. So this is my system level configuration. While in global level configuration, the configuration will be applicable for particular user, and all directories that come under this user or that belong to this particular user, they will be affected by this. So the command for this is git config -- global. Instead of system, we just use global and then the username. So for example, let me create @ global username, and if I do it list, I'll have to change system to global. Let's also change the email @Edureka _global@live.in. Right, if I do global config, if I look at the global configuration, then I have my username and my email ID set. The last level is the local level configuration, wherein configurations are applicable for particular project or directory. By project or directory, I mean, for example, this directory, I'm in temp my Edureka, and my directory is my project. If I look at this -la, I think no. So I think I have created, well, let's, for example, Edureka is my project name. If I look into Edureka, then I have my .get file created. So Edureka will be considered as my project directory. I can also create my, in the same way, I can go ahead and create my email, and I can also create my username. Let's call it Edureka plain. Now I can also remove this local, and the config option will think of it as local. For example, this I have created, for example, the local here. Same can be done with the username, wherein I have to just remove the -- local. If I list it, let's list this configuration file. So what I did is, I'm executing git config -- local and /shell, which is the option for listing the configuration belonging to particular level. Now you can see here that I have my username and email set accordingly. Let's try if it'll still get. I think it will list all the directories. Now if I remove the local from listing, then what I'll get is, it will list all the username. For example, I have my system username, I have my global username, the global email ID, and I have my local username and the local email. Now local will override the global, and the global might override the, so it will start with system, then global will override the system, and then local will finally override global. Now let me show you the get command, git config dash l dash dash help. This is the command which will list all the configuration options for you. Now we already saw this, that we can, the git config list command, we can also, the verbose way is to use dash dash list. However, you can, as I used, we saw earlier, we can replace dash dash list with dash l and we will get same configuration. I can also replace a system or global to see the only the system level, or to filter my list options accordingly. For example, the global or the local. Now these are the, as they are saying it, that we are using to list the git configuration command. So we can use git config dash dash list. This will list all git configuration command. If I put it dash dash local, this will list all local git configuration. We can use system and global in place of local, and we'll get the system or global configuration accordingly. Now we have another command which is to list down particular property. I can have the config, and if I place system, then I can get that property from the system or the global configuration. To delete an entry, we can use git config dash dash unset and then my key name. My key name is the property name, for example user.name or user.email. We can also get multi-valued parameters by getting the get regex. For example, let's get all the email get slash, let's get everything belong with user dot. So I'm getting my usernames from system, from global, email IDs, and again from the local. We can also edit the configuration by using the edit function. So if I look at the get, then you have all these options. I'm sorry, let's get the help for get config. This is my get all, where I like get, but it returns all the values for multi-valued key, while get will get the value for a given key. We can use get regex, like we already see that we can use regular expression in it. Dash dash global, system, and local we already saw, which is used for specifying what level of configuration we are acting on. Unset is to remove the line unset, and then we have to specify the key name to remove that particular config variable. Dash dash list we already saw. Then for now we have discussed only these. We have unset all as well, which will remove all lines matching the key from config file. So the git configuration options recognized by Git fall into two categories. One is the client side and the other one is server side. The majority of the options are client side, which means that configuring your personal working preferences, which includes username, email, commit template, editor, colors of the Git console, etc. And the other one is the server side or the server configuration, where not nearly as many configuration are available, but there are few interesting ones, such as there is one receiver.fsck objects, which makes sure every object received during a push still matches its sha1 checksum and points to a valid object. However, this is not done by default and we have to configure it, or we have to enable it through the git config options. So let's look at now some command line basics. Now command line is the only place you can run all git commands, because most of the GUIs implement only a partial subset of git functionality for simplicity. If you know how to run the command line version, you can probably also figure out how to run the GUI version, while the opposite is not necessarily true. Also, while your choice of graphical client is a matter of personal taste, all users will have the command line tool installed and available by default. So let's configure the Git with all the options we have. We already saw some Git commands. While let's do this all again. So in this demo, we will initiate a new Git repository. What I'm going to do is I'm going to remove the Edureka directory and let's recreate it. Let's create our project directory here, which I will name as my project. Let's initialize this as the Git directory. So I'm initializing a new Git repository, sorry. So I now have .git file place. So this git init command creates a new Git repository. It can be used to convert an existing unversioned project to a Git repository, or it can initialize a new empty repository. Executing this command, the git init will create a git subdirectory, .git subdirectory, which is here in the current working directory itself where we executed the command, and it will contain all necessary git metadata for the new repository. This metadata will include subdirectories for objects, reference, and template files. All you have to do is cd into the project directory and run the git init. You will have a fully functional Git repository available. So let's look at now the contents of config. Now if you see, our local options do not exist, so let's use git config to add the email id at local level. So I'll say we don't have to specify dash dash local because that is by default, and I'll say username Edureka and the email is, let's create live.in. If I look at this git config again, then I have my user level configuration available. Let's understand the git lifecycle. So when you first clone a repository, or when you first initialize a repository, all your files will be tracked and unmodified. All your files will be untracked initially because we have just created the repository. If we are cloning it, then all and they are unmodified, then they will be in tracked mode because Git just checked them out and you have not edited anything. As you edit files, Git see them as modified because you have changed them since your last commit or changed them since your last pull. Now if you remember, pull is the way to get the updates from the repository into your local directory. As you work, you will selectively stage the modified files and then commit them as necessary. Once they are committed, they will become the unmodified, and if I remove the file, then it will become the untracked. So how it goes is that I have an untracked file, I have created a new file which is untracked, I add that file, it goes into stage. I have an existing file, I added that file, it goes to modified, and then I stage that file using git add command. Once I commit the stage file, then they become unmodified files again, right? Unmodified means they are up to date. Now each file in your working directory can be in one of the two stages, tracked or untracked. Now the tracked files are files that were in the last snapshot. They can be unmodified, modified, or staged. In short, tracked files are files that Git knows about, while the untracked files are ones that Git has no knowledge about and they were not there when the last snapshot was taken. Now let's look at the Git lifecycle. So in step 0, we clone the Git repository or pull recent changes to an existing repository from the remote. Now the repository to clone can again be both local or remote. Like in Git, cloning is generally a one-time operation. Once a developer has obtained a working copy, all version control operations are managed through their local repository. In the next step, we add file in the clone or in the new repository. Right now this file can be new or this can be a modified file. In the step 3, we check the status using git status command, and in final step in the fourth step we modify the file and add file to the staging area. So let's try this. So what I'm gonna do is I'm gonna create, we don't have any file existing, so let's create new file test.txt. And if I look at my git status, then you can see this file is new and it is untracked. So what I'm gonna do is I'm gonna stage this file. If I check the status now, then this file is staged. Git knows about it and this can be committed. Now if I will look at the some unmodified file, or same will happen with the file which is already committed, and then we modify it, then it will become in the stage directly. Now once the file is in staging area, you can either commit it or remove it from staging area. To remove it, you can use git rm --cache test.txt, and to commit you can use git commit -m. M stands for message option, and then you can message it. You can finally push it to the remote repository by using git push origin master. Origin is the remote repository name and master is the branch name. So let's look at the status again. Now let's remove the test.txt from the staging area. So if I look at the status again, we forgot the cached option. So if I look at this status again, then this again went into untracked file. Let's add it again and let's commit this file. Now if you look at the status, then this is up to date. I can now, let's modify this file. Let's add world to this. Now the test.txt is modified. File, check the status. Now this is modified. I'll have to add it to the staging again by using git add test.txt, and then if I look at this, this is now in the staging area, and then I can commit it again. So let's write first track commit. If I look at the git status, then we are up to date. We are on branch master, and we don't have any remote repository for this because this is the local one so far. Now we have been talking about the remote repository, that origin is the remote repository name, or we don't have remote repository. So let's look at them in more detail. So remote repository are versions of your project that are hosted on the internet or on network somewhere. Collaborating with other developers involves managing these remote repositories and pushing and pulling data to and from them when you need to share your work. So to collaborate, you can use the git push and pull commands to pushing the data to the repository, and pull to getting the latest data into your repository. So there are two types of remote repository. One is the public one and second is the private one. Public one, as the name says, is visible to the public and anyone can fork or clone your repository, while the private repository is only accessible to you, or it is only accessible to people you want to share them with. For the private repository, your account must be on paid plan on GitHub to create a private repository. Otherwise, there is also Bitbucket, which I guess allows you to create 3 or 4 private repositories. Otherwise, if you want to share work, then you can create a public repository, add a license to your project, and you can share it with people. So what we're going to do is we're going to create an account in GitHub, and then what we will do is we will create a new repository. Once we click on this link, the new repository, we will get this form where we'll have to specify the repository name, the description, which is optional, and we have to specify private. We don't have, with the free, we don't get any private repository. I can also initialize a readme, which will be in markdown file for my project, and I can choose my license, which will can be Apache or any other license I want. I can also add my git ignore file, which will be used to ignore certain files. For example, if you're using Emacs editor or Vim editor, then sometimes you will have certain unwanted temporary files created, so you can ignore them. You also, if you are not interested in putting in your data files, then you can put your data folder into the git ignore file and it won't be tracked by Git. So this is the optional configuration. We can create a readme file, we can also create a git ignore, as I said, and we can then add a software license. So git ignore is very useful, that I always use. I actually use all these three and I prefer to use them. Readme is very popular and is a brave. This will be a user guide for your project. Git ignore, as I said, is also important, and the software license you can just add with one go. Once you do this and you click on create project, you will have the repository created. We can also create a Git repository using command line interface, which we already saw. So if you remember, we in the past step, we created this Git repository test, which had the file get dot. So we had this Git which had the file test.txt. If I show you the Git log, then this is the Git log we have, wherein we have created the first track commit and then we had the second commit. We will look at the Git track in the coming option. Now once we have this git remote add origin, we can configure git remote on the local repository. We have to add this. So there are two ways to do it. Once, either we clone the repository directly, which I'm going to do now, or we can have the local repository and then add this remote URL, and then we can go git push origin master. So what I'm going to do is, for this, since we are unable to do it, I'm going to clone existing git repository. So let's take it from Edureka. Let's see if Edureka should have be having a, we have a username Edureka get. I'm gonna get a very, so these are all the repository that this person have, and these are all public repositories. I'm gonna download this. Let's get this git flow. So here I can go, I can have to click on the clone with HTTPS or use git to checkout. So I'm gonna click on copy this URL and I'm gonna go here. I'm gonna go into Edureka and let's do git clone. This is my cloned URL. I don't have a git account, which it didn't ask as well. So now I have a git flow. If I look at the git branch, this will show me this is only master branch, and let's check the remote. So I have now remote available, which is origin, and I have my branch as master. So what I'm gonna do is I'm gonna modify a file in it. So let's modify readme. I'm gonna just add a space in the A and just save it. If I look at my git status now, then I have my unmodified file. I'm gonna add it all the files just because I have only one, and if I look at it, this is stage. So let's commit it. Now if I look at my git status, now this is all okay, but I have to push it. So I'll also git push origin master. So what this command is doing is that it is pushing my updates from the local to the remote repository. Remote repository is named as origin and the master is my branch name. I don't think it will allow, or if it will do, then it will be in the wait till the author will verify it or the owner of the repository will verify it. We already saw this cloning git repository local, so we already cloned that. We already covered this step. Now these are the basic git commands. So we saw the git add, which is adding file contents to the stage area. Then we have git branch, which will list create or delete branch. So I'm going to cancel this. So this is asking for git credential now, which I'm not allowing since I don't remember mine now. If I look at the git branch, then I'm getting remote. So let's add a new branch. Let's add a new branch dev. So if I do git branch dev, then I have my dev branch created, but I'm still on the master branch. I have not checked out. Now to use the dev branch, what I have to do is I have to use git checkout command, which is to check out and switch to a branch. So if I do git checkout dev and if I do my git branch, then you will see that I'm on now on dev branch and not on master. Git clone is the same that we already saw, that it is used to clone or copy the repository into our local. Git commit is to record changes. Git diff is the command to show changes between the commits. For example, we don't have any changes yet, but right, so I'm going to git checkout master. If I look at the git status, we don't have one. I'm gonna again change the readme and I'm gonna add test here. Right, so I'm going to add test. If I look at the git status, then I have unmodified files. So let's check if git diff will work. So if I do git diff, it will show me all the files that are in a stage. But if I want it for single file, then I can also specify my file name here. So if you see that this is the readme file, there is no addition or deletion. There is an update or change in the line, which is I have removed this line and replace it with test. Just the colors, the red one is removed but the green one is added. Now there is git fetch, which is from downloading objects and references from another repository. We already saw git init, which is to create empty repository. Now we can also look at git log. Now this log is giving us the complete metadata of the repository. As if you remember in the first module, we learned about that any git repository contains all the metadata. So this is what we have. So far, so many people have committed in it. If I go to, for example, in November 2nd, October 21st, but if we want to look at this is what we adding to stage. This is our username and this is our user email. Now if you remember, these are the global, since we already set the global but we didn't set the local, so it picked up the global. Now git merges to join two or more development histories. Now if you look at the branch, then we have two branches. I can merge my dev here. We have a typo in the command. Now we don't have any change in it, we are on the same. So I'm going to add this. Let's see if it will work. Already up to date. Okay, generally what will happen is that this is the command we can use to merge, since if you look at the branch, then we are already on the master branch, right? Now there's another thing which is the git alias. But to understand the alias, let's look at what the alias actually means. So alias is synonym with a shortcut. We already know this. So they are used to create a shorter command that map to longer command. This is also a feature in Linux, and this is also Git has also a similar feature. So aliases will enable more efficient workflows by requiring fewer keystrokes to execute a command. For example, a commit command, which is frequently used, can be made shorter by creating an alias. So what I can do is I have to use the git config command to create an alias, and I'm gonna use global. I'm gonna create a, or let's create local alias, and I will alias. This is the syntax so far, and CI is the alias actually, and I'm gonna put commit, right? So if I create, check the git status, I'm gonna go to git checkout, or I'm gonna add another line in readme.md, make a small change, just add number here. Now if I check git status, then I have unfinished this. Now this is moved to the, I have added this readme.md to staging area, and now I'm gonna commit it. Now initially I'll have to use commit, a small commit, but rather, since we have created the alias, I can use CI, right? And this is committed. So this is the power of the aliases that we have. So we have created local alias. We can also create a global alias with dash dash global and the alias name. For example, for checkout, I can create CO. For status, I can create ST. For CI commit, I can create CI command. Just important part, that we cannot have alias with the same name as the git command. For example, if I will try to create commit, then it does not make sense, because commit is already there, so the aliases has no use as such. Now this is the alias use case that we have. So what we are doing is we are resetting the file. We are moving the file from staged area to the unstaged area, and we are creating the alias unstaged. So if you remember, we used the git head command, this one. So I'm going to create an alias for this, which is how global alias.unstaged. So I'm not creating a global for it. I'm creating a local one for now. Now alias dot, this is my alias name unstaged, and then this is my command. I'm just gonna use reset head, right? I have to add the git config as well. So now I've created the alias. So now what I'm gonna do is, there is another alias that I can create. Now first of all, first check this, that if I have, I'm gonna edit the readme.file again. I'm gonna put it to, if I do the git status now, then this is in unstaged area. I'm gonna stage this. This is the git status. And to unstage is, if you remember, we have created the alias unstage, and this was our earlier command, git reset head. What we have to do is now git unstage. So changes have been unstaged, and if I look at the git status now, then I have readme.md again in the modified. I can overwrite it from the repository, so there is nothing to commit, and I have overwritten that file. Same way I can create another alias for the log file. So generally, to get the log, this is what I get. If I want to get the first one, then I can get this from the head. This is a small comment, this is latest one, so I can create an alias last with it. So what I have to do is, I can have to use the same command, alias dot last, and then log -1 head. Now I have to just do git last to get the status. So this way, these aliases can be very powerful when we are creating the workflows. Now let's discuss the tree architecture of the Git and the other VCS. So first we're gonna go into the other VCS. So the two tree architecture, which is used in other VCS, version control system, there are two places. One is the working copy, and second one is the repository. So working copy is the place where you make your changes. Whenever you edit something, it is saved in the working copy and it is physically stored in a disk. While repository is the place where all version of the file or commits, logs, etc. is stored. It is also saved in a disk and has its own set of files. In this process, so what is happening in working copy is that we commit something, it goes into repository, where checkout something comes into working copy. Now in this process, working copy and repository is saved in the disk as a series of folders and files like a tree. Since files and directories resembles a tree, wherein folder represents a branch of a tree and files represent the leaf. Hence, this architecture is called as two-tree architecture. The famous VCS with this kind of architecture is Subversion or SVN. So now that you know what a two-tree architecture looks like, it is interesting to see that Git has a different one. It is instead powered by three trees. Why three? Well, because Git has also working copy and the repository, but it had added an extra tree in between, which is called as staging. And this is one of the benefits of three-tree architecture. This is one of the fundamental difference that sets Git apart from other VCS. This staging tree, which is usually termed as staging area, is a place where you prepare all the things that you're going to commit. In Git, you don't move things directly from your working copy to the repository that we saw in the two-tree architecture. Rather, we have to stage them first, which is one of the main benefits of the Git. So what is happening is that we have a working directory, which is my local directory. I add the files using git add to the staging area, and then I use the git commit. Now, once it is committed, the other persons who are collaborating in the project, they can use the git pull to download the repository contents to the working directory. Now let's y3, and then again the issue is then y3 and y2. So there are some advantages of three-tier architecture which can be reflected with this example. So this is the example that we have following, that for example we have a developer called Dave which fixed two issues, which is issue 1 and issue 2, and he makes changes to 5 files while doing so. And after he fixes the issue, he commits the changes to the repository. So he fixed the issue in his workspace, and the changes are moved directly to the remote repository. Now, he later finds out that fix 1 is faulty and he needs to revert back to the previous state. The problem here is that he cannot revert back to the previous state without undoing the changes he made for fix 2. So we'll have to revert the complete fix back and then commit the fix 2 again independently. Now you might think that why we are not fixing the fix 1 and fix 2 separately, because many times it will happen that while you're working on the project, you will have to commit this fix 1 and fix. You might forget to commit the changes directly to the repository, because when you're working on a flow, you won't be fixing some minor changes again and again or committing the minor changes. However, this because the network is again an issue, right? For example, if you are in an offline area, then these things might arise. However, if you are working with the Git, which follows a three-tree architecture, then what will happen is Dave will fix issue 1 and 2 and make changes to 5 files. Now, instead of committing them directly to the repository, he will stage the file first using git add command. Now, once the files are in a staging area, he can commit two different files, or he can commit with the two different messages with issue fix 1 and the other 3 files with the issue fix 2. And now later if the fix 1 is faulty, then it can be reverted back because they are part of different commits. So we have understood the three-tree architecture. Now these are the three main stages of Git. So we already saw in the previous diagram that we have modified, staged, and commit, or we can see untracked. Untracked will also come here because we have new files. So files which are already there in the repository, and if we have modified, they will become modified and then they will be staged and committed. While if we add a new file, they will be untracked, then staged, and then commit. So how the file will move to stage using the git add command, while to commit they will be safely stored into the database by using git commit -m. -m stands for adding the message. Thank you for attending this session.